What would happen if you grabbed a shovel, started digging, and just kept going straight down through the center of the earth until you popped out the other side? It sounds like a cartoon stunt, like a stick man burrowing through a planet made of sand. But beneath the whimsy lies a rich physics thought experiment, gravity trains, Coriolis twists, and a journey that would feel part roller coaster, part pressure cooker. Imagine descending into your hole. At first, the air would feel normal, and you'd hear the distant echo of a pickaxe striking rock. As you go deeper, though, the weight above you grows unbearable. Every meter down, the rock presses harder, squeezing your body like a cool stone hug turned too tight. Soon your shovel becomes useless. The heat alone would make bare hands blister. You'd need a fictional suit to shield you from temperatures shooting past 1,000 degrees, hot enough to melt the metal of your subterranean elevator. Let's suppose, though, that you could ignore pressure and heat. What about gravity? On Earth's surface, gravity tugs you downward at a steady rate, but as you descend, you'd actually get lighter. Picture running down a basketball court. At first you sprint fast, but if the floor suddenly dipped below you, your pace would slacken. Deep in the earth, the mass above you cancels out some of the pull from below, so gravity weakens until, at the planet's center, you'd float weightless, like a player leaping for a slam dunk in slow motion. If you could hang there for a second, you'd feel utterly free, with no down at all. Keep moving past the center, and now gravity would pull you back the way you came. You'd slow, then reverse direction, like a ball thrown up into the air that pauses at its highest point before falling back. In theory, without friction, you'd oscillate, sliding from one side of the world to the other in about 42 minutes, a thrilling, endless pendulum ride. Engineers call this the gravity train, a super-fast subway that cuts through miles of rock and metal without engines, just nature's pull. Of course, Earth spins, and that changes the story. If you tried to dig straight down at the equator, the planet's rotation would whisk the ground beneath you eastward. As you tunneled inward, conservation of angular momentum, a fancy phrase meaning things keep spinning the way they were, would fling you sideways, making your shaft curve in a spiral. You might emerge far from your target, tumbling up in the Indian Ocean instead of Spain. It's like trying to dig a straight foul line on a moving basketball court. You'd end up tracing a lazy curve. Then there's the tragedy of friction and air resistance. A real tunnel isn't a frictionless vacuum. It's full of air that resists your fall, creating drag. You'd reach a terminal velocity, a constant top speed, far slower than the theoretical 7,900 kilometers per hour. And each time you passed through dense rock, you'd skid against the walls, losing energy until you settled at the center, stuck in a hot, dark chamber with no way out. This journey through Earth remains firmly in the realm of thought experiments. Wildly instructive, but wildly impossible. We've no materials to bore through molten core, no suits to withstand crushing pressure or searing heat. Yet by imagining this adventure, we uncovered deep truths about gravity, momentum, and the hidden forces at work beneath our feet. So the next time you drop a ball or wonder why Earth feels so solid under your sneakers, remember, dig just a little deeper in your mind, and you'll find an entire world of physics waiting to surprise you. If you have absurd questions, write them in comments. If they are interesting, we can make a video about them.